We're going to finish absolute value today. Today we're going to be doing the absolute value inequalities. So absolute value gives you two solutions. You know, when you do equations, most of the time you get two solutions. So if you do an absolute value inequality, you're still going to have two solutions. So the single inequality becomes a compound inequality. So you're changing your single inequality to compound inequalities. Only if it's absolute value. Only if you see absolute value bars. If you don't see absolute value bars, you do not need to change every single inequality to a compound one. Okay? The absolute value is what does that. So if it's absolute value and there's a less than sign, then we have an and compound inequality. So this means that it's an and we write it like this, where you have your x in between, and you have your negative and positive answer. That's how we write and compound inequalities if we have to write them ourselves. If we don't write them out ourselves, sometimes they're like this, and sometimes they have the word and. Okay? If it's a greater than sign, then it's an or compound inequality. When we write or compound inequalities, we write the word or. We make two separate inequalities, kind of like we do with equations. You make two separate equations and solve each one. You have one with a positive answer and one with a negative answer. Note that when you had to use the negative, you had to switch your sign. So it went from a greater than to a less than sign, because you have the negative answer. Okay, so those are the properties we used for absolute value inequalities. Okay, so we'll practice solving these. This says solve and graph, and then write your answer in interval notation. Okay, is it a greater than or less than? Less than. The absolute values by itself, we have to start with that if there were things on the left outside the absolute value. So to break it apart, to make my two inequalities, I have to know, okay, is it greater than or less than? It's less than. So does that mean that it's and or? And. All right, so remember to do and, you take what you have the absolute value of, and that's what you're putting in the middle. And between these two inequality signs, then your negative solution goes on the left, and your positive solution goes on the right. That tells you that 2x minus 7 is between negative 5 and 5. Okay, now solve. So I want to get x by itself, but I'm keeping it in the middle, so I'm going to add 7 to all three sides. So 2 less than 2x less than 12. And then we need to do what? Divide everything by 2. I'm dividing by a positive, so my signs switch or stay the same. They stay the same. Okay, so I've solved. Now I need to graph and write my answer in interval notation. Okay, so x is greater than 1, so that means right of 1. X is less than 6, so that's left of 6. And we need with and where they overlap. So they overlap right here. I need the numbers that are greater than 1 and less than 6, so that would be between. Parentheses are bracket at 1. Parentheses are bracket at 6. Parentheses. And then I have my interval from there. So it's only over what's shaded, and the only thing that's shaded is here. So x is an element of the interval 1, 6, parentheses. Questions about that? Okay, let's look at another one. Yes, sure. So, absolute values by itself. So I don't have any simplifying I have to do first. I need to look at the inequality sign. Is it less than or greater than? It's greater than, so is it and or or? Or. So when you do or, you make two separate inequalities. So what I like to do is I like to just do the first one. I do the greater than first because that is no changes. So I write the first one down with no changes. The only thing I'm taking off is the absolute value. So I'm writing down exactly what I see. 2x minus 1 is greater than 3. And then or 2x minus 1. I know I need negative 3, which since I'm doing a negative, I have to switch the sign. Negative 3. I need positive 3 and negative 3. So with the negative 3, you have to switch your sign. And then solve each one separately. So add 1, divide by 2, so x is greater than 2. Or over here, add 1, x is less than negative 1. When you graph each one separately, it's or, so it can be either or. You're not looking for the overlap here. You just graph them separately. So greater than 2 would be left or right of 2. Right. And bracket or parentheses. See? Okay. Less than negative 1, so left or right of negative 1. Left. And then bracket or parentheses. Parentheses. Okay. So x is an element. I mean, what's shaded? So I have this shaded region and this shaded region. So I have two different intervals that I'll connect with the union sign. So this first one starts off with negative infinity, so I have to use parentheses. Okay. And then union. And then the second one starts with 2 and goes to positive infinity. Okay. Questions about that one? All right, let's look at another one. get the absolute value by itself first. So we have a couple things. The absolute value is being divided by 2 and then added by 6. So you know when you are solving, you're working backwards. So you're going order of operations in reverse. So you need to take care of the plus 6 first. So we'll have to subtract 6 from both sides. That's 2. And then how do I get rid of that 2? Multiply both sides by 2. Now that the absolute value is by yourself, this is where you do the compound inequality. So is this greater than or less than? Less than. So is it and or? And. Okay. So with and, you put your 3w minus 2 in the middle. If this had been less than or equal to, you would have less than or equal to signs down here as well. So if there's an equal to, keep it equal to. If there's not, then you don't put it there. Okay, so on the left, I have my negative 4. On the right, I have my positive 4. So what should I do first? Add to, make sure you add it to all 3 sides. And then divide by. Don't be afraid of fractions or decimals. Keep it as a fraction, so negative 2/3. And then 6 divided by 3 is 2. So negative 2/3 would be left of 0, and then 2 would be right of 0. Again, I need what's in between those, because I need it to be true for both. I have to overlap right here, parentheses, parentheses, because I don't have any equal to. Oh, so W, that's my variable, is an element of the interval negative 2/3 to 2. Questions about that? Okay. Let's look at some special cases. So just like those equations, when you see absolute value and a negative, that should make you stop. We're not going to be able to continue to solve this because we have absolute value by itself and a negative. Okay, but this is not always no solution. We have to, again, read our inequality. So absolute value is always positive. So no matter what I plug in for x, I'm going to get a positive number here. So is a positive number always or never less than or equal to a negative? Never. A positive number is never less than a negative. So this is false, which means it's no solution. Okay, remember, it's because I see a negative number that I stop. I have absolute value and a negative. This was just an example. This is number 48 from your book. Okay, absolute value is not by itself yet. Absolute value is not by itself yet, so I need to subtract 8. Okay, then I stop because I see absolute value and a negative. Okay, absolute value is always positive. Is a positive number always or never greater than a negative? Always. So this is true, and this is where we have our all reals. You know, so we can write it like x is an element of the real numbers. You can write it either way. In Schoology, you know, I'm not making you use those symbols, so you would write all reals, okay? Or if you are real numbers, but all reals. It will tell you how to write it too. Yes. Yes. Okay? Yes.
Would it be the same case if it was like greater than or equal to -2?
Yes, because 0, so a positive number will always satisfy the greater than part, so you don't have to worry about the equal to. Yes. Yeah, so this number, this is a positive, right? Absolute value is always positive. So a positive number can never be less than a negative number. But a positive number will always be greater than a negative. Will always be greater. Never less, always greater. Yes. But on this, I can write this in interval notation. So, and this is U. U is an element from negative infinity to positive infinity. So this is really how I'd like you to write it. Now, you're not going to write that in Schoology, but on a quiz or on your paper, because you can do the interval notation. In Schoology, you can write all reals, and it'll say how to write your answer. If I want that, then it would be a multiple choice question. Okay? All right, we're going to do a couple word problems. Okay, so word problems that give you your equation or inequality are not hard, right? Because that's usually the hardest part of a word problem is getting it set up. But this one's already set up. It also tells you what G represents, so you don't have to worry about, stating what your variable is or anything like that. All I need to do is solve this inequality. So what should I do first? Add 1400. And then divide by 28. $1,400 divided by 28 is 50. I divided by a positive, so my sign stays the same. Okay, now it's absolute value inequality, so I need to make this a compound inequality. Is it and or? And. So I take what's inside absolute value and put it in the middle. On the left, I will have what? Negative 50. On the right, I will have positive 50. Okay? And you're going to add 350 to all three sides. we need to make sure we're answering the question. So there's a solution, but I want to answer the question. And it says, find the range of depths that offer the best fishing. Answer using simple inequalities. Well, so this is using inequalities. So we can leave our answer like this. The only thing is that we need to add our labels. So the optimal fishing depth is between 300 and 400 feet. But we can leave it like this because it says simple inequalities. Yes. Well, first of all, in Schoology, this one would be multiple choice because of the inequalities, and but no, I mean, you wouldn't have to do it with the inequalities, but on the word problems with equations, on this one, I have the labels for you, so you just have to write the number. Okay. All right. So again, when the inequality is given, it's not too hard. On this one, it's not given to us, so I'm going to talk to you about how to get it set up. Okay, so let's start with the answer. Let's start the answer, and then we're going to work our way backwards to set up the inequality. Now, in this case, it doesn't ask you to write the absolute value inequality. It does not ask you to represent this like that. So we could really stop at the answer, but there are times, there are questions that will say write the absolute value inequality. Okay, so let's first talk about the answer. So the average number of cars is 726. It says that number does not vary more by 235. Okay, so what is the least amount of cars that will be on the road? Okay, 491. How did you get that, Maya? Right, so she subtracted 235 from 726. So that's the minimum. And then what would be the maximum amount of cars? Sorry, say it again. 961. And you added, right, so 726 plus 235. Okay, so that's the minimum to maximum. So somewhere in that range is the number of cars at any time of day. Okay, so let's write that as an inequality. So let me first get a variable. So C is the number of cars. So the number of cars will either be between 491 and 961. So between tells me I need this, I need an and. Okay, can it equal 491? Yes, and 961. So these have equal to's. Okay, so I'm working backwards. Remember, I got to 491 because I did 726 minus 235. And I got to 961 because I did 726 plus 235, right? So I got to those numbers? Okay, so here's what where it starts to get a little tricky about what we're thinking about doing. So what number is the exact same? 726. So my 235, one's negative, one's positive. So my 726 is what I have to put inside. And is a 726 positive or negative? It's positive. So to make sure I'm adding it everywhere, I need it subtracting here. Okay, so that tells me I have negative 235 on the left and positive 235 on the right. So let me stop and let's talk through that again. Okay, so to get to this, I have 726 plus 235. So I'd have to add it here and add it here. Okay, yes?
Why do you have to keep going after you found out the 491?
So in this question, it doesn't ask me to have the absolute value inequality. It doesn't ask for the equation or inequality. But I'm showing you because there's some problems that do. Okay, so the reason why I moved this 726 because I have to keep things the same. Like I couldn't put plus 235 here, the 235 here, because if I put positive 235, then I would subtract it here and subtract it here when you're moving it. So the 726 is what was the same, and I want to add it to get rid of it here. I want to add it here and add it here to get my numbers. If I had this, then to get rid of it, I'm subtracting. And then I end up with negatives, and that doesn't make sense to have a negative amount of cars. Okay? Once we get to the very, very end, too, I will talk about that sign some more. Let's see, minus 726. Okay? Now, let's change this to an absolute value. So it's an and. So this goes in my absolute value bars. Well, yeah, 726 is between those two numbers, but at any moment, it's not always 726. So C represents the number of cars anytime. The average is 726, but it's not always 726 every minute of the day. Because I need it added here and here. Because I need to, okay, I'm trying to get to this number. So if I put 726, C plus 726, then I would have negative 491 and negative 961 over here because I would have to subtract it from both sides.
So when you give it in the equation, like before you talk about that.
Yeah, I'll talk about that once we finish setting it up here. Okay. All right, and so then, because it's an and, it's less than or equal to, and then 235. Okay, so here's my answer. This is the absolute value inequality. So what it says, okay, the number of cars here, this is the number of cars, and let's say that this number is bigger than 726. So that I want to know how much does it differ from the average. So this word varies. Another word for varies would be differs, right? You know, how much is it different from the average? Different differs, and difference is why we have a subtraction there. So how much does it differ from the average? So if it's bigger than 726, we do the absolute value, it's still positive. But the reason why we have to have the absolute value is because if this number is less than 726, then I get a negative number of cars. That doesn't make sense. So that number, so no matter what, I'm staying within this range of 235. So that number is less, the difference between the actual number of cars and the average is less than or equal to 235. The difference between, that is why we have subtraction here. Does that make sense? If not, anyone has a question, they can ask me about it, and I can maybe try to explain it a little bit different. So finding the range, if it never varies, so the average, if it never differs, difference, we have to subtract. You wouldn't add here because it's not saying the sum or anything. If the number of cars was, let's see, 800, then 800 plus 726, that's more than 235. You'd be looking at something else if you were wanting to add those. So in general, if you're having to write this, let me show you just in general how to write these. You don't always have to work through this process. Now you can work through this process if you kind of forget. So this number is going to always be your range or your variation, whatever word they use. They could use ranges, from, varies from, differs from. When you're talking about between, you have to have less than. So in these types of problems, it's always going to be less than or equal to. Mm-hmm. Like from here to here? Because this is the same thing as this. This is this. This is a way to write this. I've learned how to use the absolute value, right? I just changed this from a compound inequality to absolute value. What we've been doing in this section was solving these, so going from here to here. Okay, so this is going to be your range, this is going to, or variation, however they want to say it. It's always going to be less than, and you are always going to be subtracting. Because when you're talking about a range of something, you're wanting to know, the difference between two numbers is only going to range by so much. It's only going to vary by so much. And then your original number, or the average, goes inside the absolute value. Okay, so having this, then you can kind of just, basically fill in the blanks here if you're doing this. Anything else I could answer about this? Okay. All right, that is all